10th CBSE Mathematics, Chapter Arithmetic Progressions. After watching this video, you will be able to find the sum of the first n terms of an arithmetic progression. The general form of an arithmetic progression is given by a plus d, a plus 2d, a plus 3d, and it goes on. To find the nth term of an AP, we use the formula Tn is equal to a plus n minus 1d, where here a will be the first term, d will be the common difference, n is the number of terms. To find the sum of first n terms of an AP, we use the formula n by 2 into 2a plus n minus 1d. Here a is the first term, n is the number of terms, and d is the common difference. We can use another formula to find the sum of first n terms of an AP, that is Sn is equal to n by 2 into a plus l. This formula can only be used when you will know the last term of the arithmetic progression. Here L is the last term. Now let us find the sum of first 10 terms of the arithmetic progression 1, 8, 15, and it goes on. So let us find the sum of first 10 terms. First let us find A. So a is equal to 1, d is equal to t2 minus t1. So it is equal to 8 minus 1, which is equal to 7. We see that this formula cannot be used because we do not know the last term. So let us use Sn is equal to n by 2 into 2a plus n minus 1d. Let us put the values. Here we also know that n is equal to 10 because we have to find the sum of 10 terms. So S10 is equal to 10 by 2 into 2 into 1 plus 10 minus 1 into 7. So solving this, we get S10 equal to 5 into 2 plus 9 into 7, which is going to be 63. S10 equal to 5 into 65. S10 is equal to 325. So the sum of first 10 terms of this arithmetic progression is 325. Let us find the sum of all the natural numbers between 92 and 166 which are divisible by 5. The test for divisibility by 5 is that the number should end with 0 or 5. Let us look at the numbers between 92 and 166 which are divisible by 5. 93 and 94 are not divisible by 5. So the first number will be 95, the next will be 100, then it will be 105, and it will go on, and the last number which will be divisible by 5 for this range of numbers will be 165. Now here we have a as equal to 95, d as equal to t2 minus t1. So it is 100 minus 95, which is equal to 5, and our tn is equal to 165. Now we have to find Sn. Now to find Sn, let us first find n. For this we will use Tn is equal to a plus n minus 1d. So 165 equal to 95 plus n minus 1 into 5. Solving this, we get 70 equal to n minus 1 into 5, or n minus 1 equal to 14. N is equal to 15. Now we have the number of terms as 15. For finding out Sn, we use the formula n by 2 into a plus l, because we know the last term is 165. Substituting, we get 15 divided by 2 into 95 plus 165, which is equal to 15 divided by 2 into 260. Solving this, we get the answer as 1950. So the sum of all the natural numbers between 92 and 166 is 1950. The sum of first 7 terms of an arithmetic progression is 77, and that of 17 terms is 442. We have to find the arithmetic progression. If we have to find the arithmetic progression, then we have to find A and D, which is the first term and the common difference. We know that the sum of first n terms of an AP is found by using the formula Sn is equal to n by 2 into 2a plus n minus 1d. It is given to us that the sum of first 7 terms of an AP is 77. That means n is equal to 7 and Sn is equal to 77. Let us put the values of n and Sn in this formula. So we have 77 equal to 7 by 2 into 2a plus 7 minus 1 into d. Now solving this, we get 77 equal to 7 by 2 into 2a plus 6d. 77 equal to 7 by 2 into 2 into a plus 3d. We have taken 2 common here. We divide 77 by 7, we get 11 equal to a plus 3d. We mark this as equation 1. Now the second part of our question says that the sum of first 17 terms is 442. So we have n as equal to 17 and Sn as equal to 442. Let us again use the equation Sn is equal to n by 2 into 2a plus n minus 1d. Substituting, we get 442 equal to 17 by 2 into 2a plus 17 minus 1 into d. 442 equal to 17 by 2 into 2a plus 16d. 442 equal to 17 by 2 into 2 into a plus 8d. 442 divided by 17 is 26, so 26 equal to a plus 8d. Now mark this as equation 2. Now if we solve the equations 1 and 2 simultaneously, then we will get the values of a and d. So we have a plus 3d equal to 11 and a plus 8d is equal to 26. Subtracting, we get minus 5d equal to minus 15 or d equal to 3. Now substituting d equal to 3 in equation 1, we get a plus 3 into 3 equal to 11. So we get a plus 9 equal to 11 or a is equal to 2. Since we have a and d, we can find the AP, because the general form of the AP is a plus d, a plus 2d, and it goes on. So we have a as 2 and a plus d as 2 plus 3. Then in a plus 2d we substitute 2 plus 2 into 3 and it goes on. So we have 2 comma 5 comma 8. This is our arithmetic progression. Let us take a real life example where cans are displayed on the shelf of a grocery store. There are 16 cans in the first row, 14 cans in the second row, 12 cans in the third row, and so on until the top row has 4 cans. We have to find the total number of cans used in the display. So let us first write the number of cans in each row. So we have 16 in the first row, 14 in the second row, 12 in the third row, and it goes on till there are 4 cans in the top row. Now let us first see if this list of numbers is in arithmetic progression. For this we find d is equal to t2 minus t1, which is equal to 14 minus 16 equal to minus 2. Let us look at the list of numbers. The common difference between the terms is minus 2. Hence, this list of numbers is in arithmetic progression. Here a equal to 16, tn equal to 4. Let us first find n, the number of rows. For this we use tn is equal to a plus n minus 1 d. So we have 4 is equal to 16 plus n minus 1 into minus 2. We'll have minus 12 equal to n minus 1 into minus 2. So we have 6 equal to n minus 1, n equal to 7. So we have 7 rows. Now we have to find the total number of cans used in the displays. We have to find S7. To find S7 we use the formula Sn equal to n by 2 into a plus l. Now here S7 equal to 7 by 2 into 16 plus the last term L is 4. So S7 equal to 7 by 2 into 20. Solving this we get S7 as 70. So the total number of cans used in the display are 70 cans. In this video we have learned to find the sum of first n terms of an arithmetic progression.